So the sixth and last of our six application models in this series of videos is on fixed costs. The template for the textbook example, as always, is contained within the reading subfolder of the 05 underscore integer underscore OPT folder. And for the last time, although I'm not going to go through the 8th chapter 15 exercises in neither videos or classes, there are great examples you do on your own as part of your chapter readings. So, K&L Designs from chapter 14 must decide whether or not to produce in a particular quarter, which were autumn, winter, and spring, so three of those. So in addition to the production and inventory continuous variables, we have the three binary variables on producing or not producing in a particular season. Again, the key to the model is using the binaries to create the binary constraints on the production capacity, just like or very similar to the way it was handled for the General Appliance Corporation and the decision to add this new plant, and treat that capacity as sort of variable depending on the plant is built there or not. So it's a similar idea. Okay, so the net production is then just going to be the difference between the production and inventory, and that has to meet the given demand, as is detailed out in this file on these last few pages of chapter 14. The overall cost, including production, inventory, and these fixed costs, right, based on whether or not a particular season has any production or not, right? So again, please check the details on these pages for this example, right? Then consider our own example shown at the bottom of the slide, okay, which is very similar, except that the 0-1 decisions on whether or not to produce anything in a particular clothing line, of course, for a particular time period as well, which is not really emphasized here as much, right? Because each of these production lines, or product lines, I should say, have their own fixed costs. Their objective is slightly different. Instead of minimizing total cost, it is to maximize the overall profit within the available labor and material constraints, all of which will be sort of shown here in the model. Okay, so we'll start by quickly calculating the ratios of selling price to the variable cost per unit. Okay, that was not right. To the variable cost per unit, right? So just use it sort of without taking fixed costs into account, which obviously is not the way to go, but it can give us the idea of which product lines to consider. So the shorts with the highest ratio could be one we decide to do, then jackets with a 3.1, and then maybe the pants, right? And then skipping shirts and skirts altogether. Okay, so just to have something there. Then the effective capacity is the next thing to sort of understand here. What is the effective capacity for each of these product lines, right? So we have two things to consider. There is 4,500 of square yards of clothing, right, or textile available, okay, and then there's also 4,000 labor hours available in this time period, whatever it is. So if we are, for example, considering the production of these shorts, right, then we got two numbers to consider, right? One is the ratio of total material divided by the square yardage per unit, right, which then gives us the effective capacity of 1,800 shorts. Right, but that's not the only thing. In addition to the 1,800 shorts, we got to consider, right, the labor, which is 4,000 hours divided by 1 hour per pair of shorts, which is 4,000. Obviously, the minimum of the two is 1,800. Okay, and that's literally the formula. It is the minimum of G5 divided by C5, which is the number of units based on labor availability, comma, G6 divided by C6, which is the number of units based on the raw material availability, right? And then we got to fix the G5 and G6, all right? And then that, which is 1,800 as we know, right, needs to be multiplied by the decision whether to actually produce in this particular line of clothing, right, or not. So since this is a 1, we'll get the 1,800, But again, since the shirts are 0, if I copy paste this to the left, okay. Oh boy. Okay, so we'll copy paste this in a minute, because right now I have some issues with the formulas. All right, you'll see that the effective capacity, is positive for the product line that we're considering, obviously 0 for the ones we are not. So then, to continue, we're just going to make up some unit production, right? So I don't know. Obviously, we have to have 0 for shirts and skirts because we just decided we're not going to do that. And I don't know. Let's say 1,000 here. I don't know, 300 here and a couple of hundred here, just to have some numbers made up. Okay, to figure out the the amount of labor and material used with just some product, um, that number of units produced, right? Comma, the labor hour per unit, okay, and get the 3,500, which is under 4,000, as we know it would be because that's how we calculate the effective capacities. And the same idea here, some product of units produced with the material requirements per unit give us a number of square yardage that's less than the available amount. On the financial side, the revenue is the sum product of units produced, right, and sold, of course, with the selling price. Okay, and I guess we could fix that row and then copy it down one, or just repeat to get the variable cost, which is the sum product of units produced times the variable cost per unit, right? So the fixed cost, of course, now is associated, and it's again be a sum product of the decision to produce in a particular line or not with the fixed cost for that particular product line, right? So it's going to just pick up 1,200, 1,600, and this 1,600 for these 3 production lines. Okay, and then the profit, of course, will be the revenue minus the variable and minus the fixed cost. Okay, for this sort of made up plan, it would be about $25,000. Now, the cell to maximize, of course, is the B23. Okay, by changing all these variables here. Okay, except that, or in addition to the fact that the production decisions are binaries. And of course, the units produced has to be non-negative. The normal constraints are simply on, the labor material constraints, the standard stuff. Labor amount used is less than available, and the material used is less than available. Okay, and that LP model should do it. Okay, so we're going to hit. Okay, so I had something wrong here because I did maximize that, changing these guys. The constraints. Oh, that's the capacity is not there. I forgot the capacity constraint, so I have to add the capacity units produced has to be under the capacity, which obviously this is not going to be true. So I'm going to solve it now and get the actual decision to produce the shorts and jackets only, and then skip the production of shirts and skirts as I initially started with, but also pants as well. All right, so this might not be the politically correct decision in any particular realistic scenario, but it shows how these fixed costs example work. So I'm going to save this, switch to the presentation, and summarize. Okay. So, in this series of videos, we introduced a number of integer linear programming models that arose out of the fact that rounding continuous variables in an LP solution will simply not work. The rest of the slide, the summary slide, describes the 7 types of models, which represent a decent cross section of integer linear programming models that could be adopted to a number of different situations, as we'll do that in our lectures and assignments. So we started with workforce scheduling, project selection, proceeded with set covering, customer assignments, and facility location models, and then ended up in an aggregate production planning and fixed cost models towards the end. Okay, next we're going to work through a number of problems from the end of chapter 15 in class, and then you'll be ready to work on some more on your own for the chapter 15 assignment.